IoT and mobile communication networks. This is a very important topic because IoT and mobile communication technology are merging together, and especially in future mobile communication technologies, there are many new things that are included in the original architecture and design such that IoT services and applications can be supported in a perfect way. For example, in 5G mobile communications already, there is machine-type communication, which supports IoT in various ways. In addition, there are network slices in which the overall 5G mobile communication network is divided into specific IoT application targets. Considering all of this, naturally, IoT and mobile communication networks need to be studied together. Overall, the standardization group that is leading this is the 3GPP. This is the third generation partnership project. And there are groups, which are the 7 telecommunications standardization groups, that are producing the standards for cellular network communication. These are the 7 groups that are participating in the 3GPP activities. Radio access, quality of service, core transport network, network services, and security are the main focuses that are included. 3GPP standards are structured as releases, and Release 8 and following standards are what include IoT-based support. Looking at Release 8, we have LTE, long-term evolution, which is the 4th generation mobile communication standards, Cat 1. Cat is short for category. You can see the evolution structure here. In there is LTE MTC, which is short for machine type communication. This is talking about IoT service applications that are being supported. In addition, in Release 8, there is also LPWAN, low power wide area networking technology. The specifications of how to integrate that are also included in Release 8 of the 3GPP mobile communication standards. Then there is GSM MTC, which is Global System for Mobile Communication based MTC. And in this standard, this is another mode of mobile communication cellular technology, a very popular GSM mobile communication cellular technology that is going to be used to support IoT applications. Looking at how the standards evolved, you can see that from the LTE Cat 1 standards, they are merging and supporting LTE MTC standards, and the evolution continues on to eventually become the LTE Cat M1, which is the eMTC standard. This is now reaching into Release 14 and beyond, which is a 5th generation mobile communication cellular standard. In addition, on the LPWAN side, you have the NB-C IoT and the NB-LTE protocols combining into the NB IoT standards, which are also leading into Release 14 and beyond for 5th generation mobile communication cellular technology. In addition, on the GSM MTC domain, from its evolution, we have the EC GSM IoT technologies. And these 3 technologies that are leading into 5th generation standards are what's going to enable 5th generation mobile communication cellular networking technology to effectively support IoT-based various service applications. Looking at LTE Cat 1 in Release 8, what was in there? You can see the standards in this table, which include the modulation, as well as the peak data rate, as well as the maximum output power and power efficiency. And comparing this to LoRaWAN and Sigfox, you can see the differences right here. Some of the major things that you can see is that the power efficiency is low when it comes to LTE Cat 1. However, these devices are connected to your smartphone, which has a sufficient battery supply, and also wireless charging technologies, in addition, added in current as well as future modes. And also they are supported by base stations. In addition, however, the overall bandwidth usage and the maximum output signal power ranges, their characteristics, are more than what you see used by LoRaWAN and Sigfox. In addition, the overall data rate, as in terms of its peak service range are what are shown over here. The 3GPP first standard option for IoT is the LTE Cat 1 in Release 8. It includes transitional characteristics, which means that higher data rate than later 3GPP IoT standards, and peak data rates are between the range of 10 megabits per second to 5 megabits per second, respectively for downlink and uplink. Now, what does this mean? Well, at the beginning, at this time, it was hard to predict what would be needed to support IoT applications. So some of the data rate values that you see right in here are a little bit too high, meaning that the following standards, they would reduce the data rates and they would have advantages in power consumption and other service modes. So these numbers are relatively high for what we see now as a IoT-based support standard. In addition, the UE receiver bandwidth is 20 megahertz. Then, looking into the NIMTC and the SIMTC standards in Release 10 and 11, well, this here is for network improvement for MTC in Release 10 base, specific requirements for MTC to make the network more suitable for MTC, and congestion and overload control for IoT networks are included in here. Then, the SIMTC is system improvement to MTC in Release 11. Device triggering, high reachability from the app server to the MTC device is what is the main focus of its evolution. And of course, this is very important. Triggering requests through SMS, and this is only through LTE possible support, is another option that is included in here. Cat 0 of LTE, which was included in Release 12, well, this supports new UE category that can save the battery and extend the lifeline of the UE. The UE is short for user equipment, which could be like your smartphone, your smartwatch, your laptop computer, your smart tablet computer, as well as various other devices. Altogether, in mobile communication technology based upon LTE of 4th generation and 5th generation standards, we call that altogether user equipment, and for short, UE. Suitable for IoT technology and reduced data rate from previous standards, typically comparing it to Release 8, which were set a little bit too high. The peak data rate is at 1 megabits per second for downlink and uplink, and the UE receiver bandwidth is at 20 megahertz. The duplex type is half duplex.